Here we enter the consensus critical proposal path. Prepare proposal lets the application build a candidate block from pending transactions. Process proposal lets validators decide whether that block is acceptable. The challenge is to add smarter ordering and filtering without slowing or destabilizing consensus. You've already built the foundation: Cosmos architecture, SDK modules, and the ABCI++ lifecycle. Now we connect those pieces by writing proposal logic that shapes block contents and influences consensus decisions. At each height and round, only the selected proposer runs prepare proposal. It can choose, order, or adjust candidate block contents according to application rules. After the block is proposed, validators run process proposal independently to decide whether it is acceptable. That decision must be deterministic. Given the same proposal and state, honest validators should reach the same result. Because both callbacks sit in the consensus critical path, flexibility must never compromise safety. Before writing proposal logic, decide what better means for your application. You might optimize for fairness, priority, spam resistance, low latency, or strict sequencing. Clear goals now prevent ad hoc proposer behavior later. In Prepare Proposal, the application receives a candidate set from Comet BFT's mempool, but it does not have to accept that set blindly. Start with cheap decoding and basic checks. Drop transactions that are invalid, expired, oversized, or clearly too low priority. Then rank what remains and pack the block while respecting max bytes, gas limits, and any application-specific rules. The goal is a valid, high-value proposal without doing full execution unless it is truly needed. After transactions are eligible, the proposer still needs an ordering policy. Fee-based sorting rewards economic value, but it can crowd out important protocol actions. Type-based priority can protect Oracle updates or liquidations, but it should be narrowly defined. Account limits help prevent spam and block monopolies. The hardest part is tie-breaking. It must be deterministic, stable, and difficult to game. A strong prioritization strategy improves block quality without making ordering a source of unfairness or non-determinism. Mempool-aware logic can be useful, but treat it as local advice, not shared truth. A proposer may use its own mempool signals to choose or order transactions in Prepare Proposal. Other validators, however, may not have seen those same transactions. Process Proposal should validate only what everyone can verify: transaction bytes, decoded messages, and committed chain state. That keeps normal network timing differences from causing honest proposals to be rejected. A priority-based Prepare Proposal begins by decoding only the metadata needed for policy decisions, such as fees, message types, account state, or quotas. From there, the proposer computes a score and orders transactions deterministically, using stable tiebreakers. Then it packs transactions into the proposal until byte or estimated gas limits are reached. The key is to keep selection policy-driven, deterministic, and cheap enough for the proposal path. Process proposal is where validators stop a bad block before voting on it. Each validator independently checks that the proposal follows consensus rules and the application's mandatory policies. That can include transaction validity, ordering requirements, forbidden message combinations, block size, gas limits, and protocol constraints. The central requirement is determinism. Honest validators must reach the same accept or reject decision from the same proposal. If the proposal fails any required gate, the safe response is reject. A validator should reject a proposal only for reasons every honest validator can independently reproduce. Malformed transactions, invalid encodings, duplicates, and protocol ordering violations are safe rejection grounds because they come from consensus rules. But this transaction is not in my mempool or my clock says it is late are local facts, not protocol facts. Rejecting on those conditions can split honest validators and hurt liveness. The goal is strict validation without giving local conditions consensus power. Deterministic validation means process proposal can depend on committed chain state, block metadata, and transaction bytes, but not on private or unstable inputs. External API calls, local clocks, random values, mutable caches, and unordered map iteration can all make honest nodes disagree. Once accept and reject decisions diverge, both safety and liveness are at risk. Treat this path as consensus logic, with explicit sorting and deterministic tie-breaking wherever order matters. PrepareProposal and ProcessProposal need a clear contract. The proposer can be ambitious, rank transactions, improve fees, reduce risk, and build the best block it can. Validators are strict in a different way. They enforce mandatory invariants, such as validity, safety, and protocol rules. A block should not be rejected just because another block would have been better. Optimization belongs to construction. Correctness belongs to validation. Because proposal callbacks run inside consensus, performance is not just an optimization detail. It affects how quickly blocks are produced and propagated. Keep execution bounded, especially under heavy transaction load. Apply cheap filters first, then reserve expensive signature checks, state reads, and decoding for transactions that pass. Avoid repeated allocations and unnecessary store access. Finally, measure the path carefully. P50, P95, and P99 duration, decoded and rejected transactions, bytes packed, gas packed, and overall block packing efficiency. Production proposal logic should be boring in the best way. Bounded, deterministic, configurable, and easy to test. Cover it with unit, integration, simulation, and adversarial tests. Monitor behavior with careful logs and metrics. Avoid external calls, unbounded work, non-deterministic caches, and surprising state mutations. PrepareProposal lets the proposer optimize block construction by choosing, prioritizing, and ordering transactions. ProcessProposal lets validators defend consensus by accepting only valid proposals through deterministic checks. Keep preferences separate from invariants. That balance improves performance without weakening safety. Next, we move further through ABCI++ with extend vote and verify vote extension.